All right, let's practice our properties of congruence, and things have slid a little bit. This doesn't look real great, but right now the only properties we have, and this is which property of congruence can you use to prove that each pair of triangles is congruent, if any. So maybe there isn't even one yet. Okay, remember our options so far based on what we've covered in class is either side, 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 or side, angle, side. So let's start with A here and use the given information. Let's mark it on the figure. It says QR is congruent to SR. So the line from Q to R is congruent to the line from S to R. And ST is congruent to QT. So the line from S to T is congruent to the line from Q to T. Is there any way I can prove these congruent? None of the angles are marked, and I was given no information that would allow me to say any of the angles were congruent. So there's no way SAS is going to work because there's no angles involved. Notice here, one thing that you're allowed to assume is if there is a side shared between a pair of triangles, it's going to be congruent to itself. That's by the reflexive property. Okay, so what do we end up with? Well, notice I have 1, 2, 3 sides of this triangle congruent to 1, 2, 3 sides of this triangle. So yes, I can conclude that these two triangles are congruent by SSS, the side, side, side. Let's look at the next one. Given that PN and SM bisect each other, what does that mean? Well, where's PN? It's the line from P to N, bisects the line from S to M. Bisecting each other means they cut each other in half perfectly. So that means SM is cut perfectly in half into 2 equal pieces here. So is PN. It's cut into 1 equal piece, 2 equal pieces right there. Now what do we have so far? That piece of information gave us 1, 2 congruent sides, 2 sides in this triangle congruent to 1, 2 sides in this triangle. A third side would let SSS work, but here's our third sides. They are out here, and there's no property that would allow me to mark those as congruent. So it can't be side, side, side. My only hope is side, angle, side. And how would that work? Well, look, I have 2 sides here. If there's a way to show that this angle between those sides is congruent to this angle between these 2 sides, then side, angle, side would work. Fortunately, we have a property that we'd studied in geometry that says when you have 2 lines intersecting, those angles across the intersection from one another are called vertical angles, and vertical angles are always congruent. So based on that property of geometry, I can mark those angles as congruent. That's a property you'll want to have handy because it comes up a lot. Now, notice I have a side, and an angle between it in this triangle congruent to a side, and the angle between them in this triangle, which is side, angle, side. So yes, I can prove, using the given information and my properties of geometry, I can prove that those 2 triangles are congruent by side, angle, side. Next picture, given that BD that means perpendicular to AC. So that means that BD and AC, where they intersect down here, forms a right angle on both sides. And that BD bisects AC. So BD bisecting the line AC means it cuts AC into 2 equal parts. So AD and DC are congruent, and we know that we have right angle here and here. Okay, so once again, our options are either side, 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 or side, angle, side. Well, we have one side congruent here to one side here. Okay, we have these sides on the outside that are not marked at all, right? And there's no property that would tell me they're congruent. So again, side, side, side is not going to work. However, are there any properties that would allow me to mark anything else in this picture? And the same as we did on part A, notice BD is shared between the triangle on the left and the triangle on the right. It's in both of them. And we know BD is congruent to itself because of the reflexive property. So now what do we have? Well, I have a side and a side from this triangle on the left and the angle between it, congruent to a side in the triangle on the right, and the angle between it. That is exactly side, angle, side. So yes, I can say that these two are congruent by side, angle, side. Here's our final example. We have one pair of sides marked as congruent, and we see this line in the middle is shared by both triangles and could be marked as congruent to itself. So far we have a side and a side in this triangle, congruent to a side and a side in this triangle. So we have SS right now. Is there any way we could prove this third side is congruent to this third side? No. And none of my angles are marked. Nothing is marked as perpendicular. So this one is just going to have to go with, I cannot show that those are congruent. They kind of look congruent, but there's not enough information to use either side, 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 or side, angle, side, and that will happen sometimes.